Okay guys, welcome back to our channel. Let's get started with the problem of a day of leethood. So the problem name is minimum cost climbing stair. Okay, so you are given an integer array cost where cost of I is the cost of ith step on the staircase. Once you pay the cost, you can either climb one or two steps. Okay, you can either start from the step with index 0 or the step with the index 1. Then the minimum cost to reach the top of the floor. Okay, right. So what's the question? It's saying that, guys, let me explain you in the whiteboard. So you have given the integer array, the cost array, okay, and you have to reach to the top floor of the lift or any building. Okay, so you have to count the minimum cost of that array. Okay, so the top of the array, what do you mean by, like, if you're given this array 15 and 20, so what we have to do, we have to reach to this part of the array. Okay, and the minimum cost we have to find for that, for reaching to the top of the floor of a building. Okay, so guys, like, and also they have given to you, like, you can just a second, just forget about the step. You can either start from with the index 0 or the step with the index 1. Okay, so we have to take care of this case also. Maybe the answer should be coming from the index 0 or the step index 1. Okay, and you can either take climb one or a two step. Okay, so like, suppose if you are starting from this floor. Okay, so suppose if you are starting from this floor, okay, so 0th floor, you can take n minus 1 step. Okay, and minus one step and one step, or you can take the two step. Okay, and suppose if you are taking this for the 0 index, if you are taking considering this array. Okay, so if you are taking this, you can jump to this first index. Okay, so if you are jumping with this index with the with the step of n, with one step. Okay, so if you're reaching with this step, you are getting answer as 10 plus 15. And also they have said to you clearly in the question, you have to, once you pay the cost, okay, step on a staircase with once you pay the cost. Okay, then you will be able to climb one step or a two step. You can see here. Okay, so right, so if you just see, if you're saying that we have to pay this cost, so we are adding 10. Okay, so current will be 10, and if you're starting from this, and if you're considering n minus 1, then it will be at a one position of index. Okay, and if you're again taking this array, if you're taking again this array, so 10 plus 15. Okay, and if you're considering this also, then it will give you the 10 plus 25, 25 plus 20, 45. It will giving you after taking in the one step. And if you're taking the two step, like if you're taking n minus 2, okay, n minus 2, so if you're taking 10 plus 20, and you are reaching to the top of the array. Okay, so it will give you the minimum cost. Okay, but the question I've said that you can start with a 0 index. So the 0 index, the minimum we are getting from 30. Okay, so if suppose we are starting from this array 15 array, so let me just erase that, it's kind of a messy looking. Okay, so just a second. Okay, so okay, so what we are doing, if you are starting from this array, okay, so if you are starting from this, you can take one step, so it will be give you the 15 plus 20, so it will give you the 25 answer. Okay, and if you're starting from this array, if you're taking two step, okay, so the minimum step will be n minus 2. So if you're taking this n minus 2 and you're reaching to the top of the floor, the minimum answer will be 15. Okay, and then the output you're getting from is 50, because the answer we are getting is it is minimum from all the above answer which we are getting. Okay, so that's why we are giving taking this answer as a 15, which is giving us the minimum. Okay, so if you want to see in a recursion way, I will show you, just a second. Okay, so what we have given, like, we have given the if you're considering this 10. Okay, so we are calling for recursion 1 for 10, and if you're taking this as n minus 1. Okay, so if you're taking the remaining array will be 15 and 20. Okay, and if you're taking n minus 2, the array will be 20. Okay, it will be 20, so it will again consider the step. Okay, so they are, then after it will be no step left for the top of the floor, because you are able to reach the top of the floor, so you will simply return your answer. Okay, so if you're considering this array, so you just take 10 and 10 plus 15. Similarly, the 10 plus 15, Okay, and if you're considering this again for a two-step, so it will give you 10 plus 20, which is give you the 10 plus 15 plus 20, it's give you the 45 answer. Okay, and similarly if you're considering for the shorter index, like if you're considering 10 plus 15, and if you're going there in a two-step, you are reaching to the top of the floor. So in 15 you are getting the minimum answer like 10 plus 15 plus there is no index array left behind, so you are getting minimum answer for 25. Okay, so this is a minimum for 25, sorry, for 15 you are getting. Okay, and for 20 you are the array is not left any number left behind with it, so that's why we are not getting any answer, so we will return 0 from there. Okay, if you're not getting the answer, you are just giving the return the value only. What is the value? It will be written 20. Okay, and similarly for this case, you are getting the answer as a minimum from comparing all these numbers. Okay, so 25 is the minimum, and you can see the overlapping of the problem. So you can see that overlapping of the problem. Okay, so why we just go to the same part again and again, we can use a recursion array also. Okay, so let me just show you the code part, because it's like a very easy question, but I have done the mistakes, like it's kind of a mistake we are getting. Like if you show my array, I am just getting time limit exceed array. So why we are getting time limit exceed array? Why? Because I've taken the recursion array. Okay, so what we are doing, just I'm taking the cost dot size, and I'm just calling the recursion function, and it will give me the return, give me the answer only, just the minimum answer which we want from n minus 1 on n minus 2. Okay, so what we are doing, just if the n equal to 0, just return the cost of 0. Okay, so if it goes to the negative answer, so I just don't want that negative answer should come to my answer, so I just ignoring that, and I just got the if they go to the base condition like n equal to 0 or n equal to 1, so it just gives me the return cost 1 or cost 0. Okay, similarly, and I'm just also including the cost of n, because the question I've said you have to only move when you just include that the cost of that ith index in which you are. Okay, and after doing so, I'm just calculating the minimum cost from these n minus 1 and n minus cost and n minus 2. You can see from this. Okay, I'm just calculating this only for this minimum cost, and for this also minimum cost. Okay, I'm just calculating that, and after doing so, you just give me the return the answer. Okay, and after running this code is giving me the time limit exceed for the higher value, because it will not run into again and again into a loop path. So that's why the recursion is quite a possible, but you can go to the other part of a DP, so it will give you the time, won't give you the time limit exceed error. Okay, so what we are doing, I'm just giving the second part which I have done. So what we are doing is like it will be a top up approach. Okay, so what we are doing is like we have taken the cost dot size array, and we are initialized with the DP of -1. Okay, and similarly we are doing for this part only. Okay, so if we reach the base condition like n equal to 0, just return the cost of 0, and if we reach the n equal to 1, just return the cost of 1. Okay, and if you have calculated the answer for DP of n minus 1, you just return that answer. Okay, and from this we are just storing the answer. Okay, from here. Okay, and just return the DP of n. Okay, so this code is running fine. Okay, so it will be passing by all the test cases. Okay, so another form of the answer which you can do is it's the tabulation form. Okay, this is called a tabulation form. Okay, so tabulation form is a kind of a very easy form. Okay, so what we are doing, just we have just take the array part, cost array, and just return the solve of n cost. So what we are doing, we are again considering a base condition. So these all are my sorry, just a second, these all my base condition. Okay, these all are my base condition. Okay, these all. Okay, just a second. Okay, so these are all my base condition, and similarly what I'm doing, I'm just starting my loop from I equal to 2 and I less than n. Okay, and what we are doing, just for the ith one, for the second index, you just include the cost, and please also find the minimum cost from these DP of I minus 1 and I minus 2. Okay, so what we are doing, just in a second, just a second. Okay, so what just a second. So if it is given x 10, 15, 20, so we are just storing into a DP array which is for dp0 it will be like 10. Okay, just a second. Okay, and for dp1 it will be like 15. Okay, and if you're just store that answer array, you just calculate for go to the loop part for int I barabar equal to 2 from I less than n. Okay, you just go to the part. Okay, and you just if you just go, you have to just find the minimum part from the array, minimum part. And if you just see that, if you go see that our size is 2, our size is 3. Okay, so it will go to the loop and it will calculate the cost for the minimum answer we are getting from the array. Okay, if it is go to the loop, it will see that dp of 2 and dp of 2 is 20, and it will see that for 20 it will see that for n minus 1 and from n minus 2 we are getting 10, so it will store for 30. Okay, it will store for 30, and after doing so, what we are doing, we just return our answer from the dp array from n minus 1, from n minus 1 and from dp of n minus 2, because from the last index. Okay, so we are not including this part in a tabulation form. Why we are not including this part? Because we are considering that this is our top floor for the dp array for a tabulation form, but for the recursion and dynamic programming we are considering this part for a top of the floor. Okay, so that's all from our side. So if you have any kind of a down still for dp, you can ask me on a comment box. Till then, good night guys.